Okay, we're talking about the DC offset again, okay? Make sure you have to understand it. That the JFET, that the Johnson field effect transistor, okay? They get, this is the symbol, okay, for N channel and a P channel. Same like the bipolar transistor. You get NPN and PNP. Okay? They get the drain, the gate, and the source. Same thing. The difference is arrow right here, going in N channel, going out P channel. Okay? And they get the applied voltage VDD. Okay? Connect to the drain. Okay? Okay, this will be showing what? If you see they connect the meter for the VGS and the current meter to the current of the ID. So basically, you can see the voltage very more negative. However, the current will be small. Okay? The thing is, this is the drain, this is the source, and this is the channel for electron moving. Okay? And another one here showing you what? The channel now will be bigger. Okay? So negative current will be, a voltage will be going down. And now the current will be going up. That means there's a channel here for the current moving from the drain to the source. Okay? And this is a symbol when you're working on the lab for JFET. Another thing, they can give you the current will be flowing more. The thing is the channel will be wider. Okay? When you get a lead current, okay, of the VGG or at the gate, then the current at the drain will be more. Okay? The thing is the channel here wider. Basically, for the JFET, okay, this stands for current ID. Okay? And now you can see ID at this point will be a 0. And that will be a VDS. That means the voltage from the drain to the source. Okay? When the current going up to a certain point B, okay, that means at the point VDS equal VP. That's what they call a ping off voltage. Okay? And what happened? That means the current ID now will be constant. Okay? They will be a constant with the VGS equal 0. Okay? And the current now will be equal current they call IDSS. Okay? Basically, the current IDSS being made from manufacturer. When they build the JFET, they given to you the current ID at N. Okay, and with to you, make sure if ID equal ID at S, that means VGS equal 0. That's an important thing. Okay, and the current ID equal ID at S at the beginning with the VP. Okay, VP we call ping off voltage. And the current keeps constant up to a certain point. They break down. Okay, no more. So this what they call from the left to the side here, a constant current area. Okay, and this is a summarize everything. Okay, you need to reading over. Okay, the maximum drain current out of the FET occur when the gate to the source voltage is 0. That means VGS equals 0. Okay, ID will be equal IDSS. That's the drain current. Okay, the drain current is almost constant in the region between VP and VDS max. And VP that given by manufacturer. Okay, we cannot make it. If the drain voltage is too large, the JFET will be breakdown. JFET acts like current source when it operating along the almost horizontal part of the drain curve between VP and VDS maximum. The minimum voltage of VP will be called ping off voltage. Okay, that means at the VP ping off voltage, the current ID will be equal ID at S. The maximum voltage VDS max, they call a breakdown. Okay, between ping off and the breakdown, the FET act like current source with the value ID at S. Okay, IDSS stands for the current from drain to source with the source gate. VGS equal 0. Make sure you understand. Every time you say ID equal IDSS, that will be telling you VGS equal 0. Okay? And almost region, that means the FET can look like to be a resistance. Okay? Cut off voltage. VGS that make ID approximately 0 is what we call cut-off voltage, VGS off. Okay, VGS off and VP all the time given, the same value. The difference will be opposite polarity. Okay, VGS off equal negative, VP equal positive. But the value, same thing. So that's why manufacturer every time they given the value either VGS off or VP. Only one, not two. If you know VGS off, you know VP. Okay. The JFET must be operated between VGS 0 and VGS off. Okay. Comparison, upping up and cut off. VP is the value of VDS at which the drain current becomes constant and is always measured at VGS equal 0. Okay? VGS off and VP are always equal in magnitude but opposite in the sign. Data sheet usually will give either VGS off or VP. Okay? Not both. Okay? The thing is that summarize what you need to know. Otherwise, when you're reading in the textbook, they get too many details that not really need for you. Okay? And now you can see this is the drain and for the drain current. Okay? This stands for current ID. This stands for VDS. So you can see at a certain point, I pick up one point right here. That's what we call a Q point. So at that point, they will be telling you current, okay, VGS equal here, minus 2 volt. If you go to the left, you can get at this point, ID. If you going down in here, you can get the point for VDS. Okay, so basically, when they calculate VGS Q. That means they want to know where is the Q in here. They can be here, they can be here, okay, they can be any time in here. Okay, so basically the current ID changing depend on the Q here. In here you get a different ID. So JFET will be a voltage controller device. That means you change VGS, you change the current ID. And okay, in the bipolar transistor, there will be a current divider, okay, current controller. JFET is a voltage controller. Okay, the thing is that in the NPN PNP transistor, okay, the current depend on the current going into the NPN or PNP. Okay. Now, at cutoff voltage, okay, ID equal 0. The meter shows nothing. And the voltage maximum, however, they will be maximum at VGS off. Okay. Basic operation, P channel. Normally we deal with that. Most of the time will be N channel. The difference between P channel and channel, you see the arrow right here, okay, coming out. And the VGG For N channel, they be negative, P channel positive. And also VDD in the N channel, they positive. In the P channel, they be negative. That's the difference. Okay. This is just an example, and we already done. They fed so they given VGS of minus 4 volt and IDS at 12 milliamp. Okay. They said the determine minimum value VDD required to put the device in the constant current area. Okay. And if you go through it, they said VGS of minus 4 volt, VP 4 volt. Okay. Minimum value VDS for JFET to be is constant current area. That means VDS equal 4 volt. In the constant current area with VGS equal 0. So ID will be equal IDSS. And they calculate the voltage across RD. Okay, voltage across RD is 6.72 and apply the Kirchhoff law around and they calculate the VDD. Okay, that's only thing. If you get the time, you can go in depth. Okay, JFET transfer characteristic curve for N channel. ID equals 0 when VGS off. They're telling you at this point here, if you want to ID, and you can see ID equals 0. And at the point IDSS, then VGS equals 0. That means at this point you're going down, looking VGS off equals 0. Okay, that is the transfer characteristic curve, okay, for N channel. And now, in order to get the calculate the current, okay, and this is the formula. Okay, VID equal IDSS. Okay, time 1 minus VGS over VGS of square. Okay, that is how we can calculate the current ID. It's the first formula you need to know. And this just an example. Okay. So they given the data set for the JFET. Okay. Okay. And IDSS given 9 milliamp. VGS of minus 8 volt. Okay. And they want to determine the drain current ID. Okay. And that's what they given. You know the formula here. ID equal IDSS 1 minus VGS over VGS of square. And you're able to calculate that. Okay. Also, for the forward transfer conductance, GM is the chain in the drain current for a given chain of VGS. That means when you change, okay, in the current ID, that will be also they will be changed in VGS. GM basic definition, delta ID over delta VGS. Okay. However, the unit of GM is Siemens. Data sheet normally given the value of GM at VGS equals 0 is GM 0. So normally when they build a JFET, they given you the basic value for GM, okay, at VGS equals 0. Okay, make sure GM 0, that means calculate at VGS equals 0. So the formula to apply, you can calculate the GM equals GM 0 times 1 minus VGS over VGS off. If they don't, they not given to you GM 0, you can calculate GM 0 by this formula. GM 0 equals 2 times IDSS divide absolute value of VGS off. The thing is GM 0 cannot be negative anyway. Okay, so basically that's just an example to calculate GM, and the current. Now, GMDC bias. Okay, basically, if you want to keep growing, then you have to know every transistor, NPN, PNP, or JFET, they need the power supply, DC power supply, to make it working. Okay, that we have to do with what they call DC bias. So for the JFET, first bias they call a fixed bias. Second will be cell bias, and the voltage divider bias. That's the only thing we want to emphasize. Okay. Now, for the circuit shown here, you can see negative voltage apply here. Okay. And that is VDD. This is a fixed bias. The thing is they get a negative voltage apply. Okay. Basically, they need two power supply. One will be negative power supply. One will be positive. Okay. In this, the display here, okay, they telling you one thing. RG, that means the resistor here will be very high. For this case, 1 mega ohm, that only telling you the current cannot flow through big resistance. Okay. So that will be telling you this is the VP right here. VB. VG, sorry. Okay. And the current flowing here equal 0. Big resistance. That's only telling you VG equal minus VGG. The reason they know what the drop across RF, RG. Sorry. Now, why they need that? The thing is when they get the amplifier, this is an amplified circuit. Input apply a sideways. Okay. and you understand it that this is a DC circuit. If you want to get an amplifier, then they're not using this simple. They're using the simple for AC. That means any DC voltage on the circuitry will be ground. That means they will be ground at this point, and they will be also ground at VG. Okay? If you don't have the resistance here, they ground it. Okay? That means the sine wave cannot go to the gate. They go to the ground. So that's why they need this resistor. Guarantee signal can go into the input of the FET. Okay. One of the most common way to bias the FET now will be cell bias. That's the second one. Okay. If you're looking into the circuitry, no more voltage here. You get only one VDD. So basically, they need only one power supply, not two. Okay? So this is what we call cell bias. One of the most common way. Bias, they fed with cell bias. Only single power supply is yield the drain supply voltage, VDD. We need the graphic. That means for the cell bias, they supposed to given you one graphic. Basically, on that, you're able to calculate the current, anything. And if you go up to the engineering level, then they will be going to the detail. However, in electronic, we don't need technician, we don't need that. But I still go through. Make sure you get an idea. Okay? How do we calculate it? Even we not apply. And the next one, voltage divider bias. You already get along with the voltage divider here. Okay? Since the gate source junction has extremely high resistance R1 minus R2, voltage divider practical unloaded. Voltage divider bias is more stable than either gate or cell bias. However, again, they will be need a graphic. So normally they prefer voltage divider bias. Okay? But like the cell bias, they need the graphic. Now, this is the example. Make sure you understand. Okay? For fixed bias, they get 2 volt apply. Okay? Let's see. They want to know VGSQ, IDQ. VDS, VS, VD. Okay? They given to you IDSS and VGS off. Okay? If you want to calculate the VGS basically equal VG minus VS. And VG equal minus 2 volt. VS equal 0. That will be telling you VGS equal minus 2 volt. Okay? And then you using the formula ID equal IDSS times 1 VGS over VGS of square. We're missing square. Okay? And that you can calculate the ID. VS equal 0. Right here. So VD equal VDD minus ID times RD, given you that value. But very important thing to you is always ID and IDSS will be the same. Okay? And now, this one, we can go into little detail here. They given the circuitry here. If you're looking into the bias, they will be cell bias. No power supply here. However, they given you this curve. Okay? And now, if you want to calculate the value of ID VGS, then you must be get a certain point Q here. Okay? Then you go to the right, you get ID. You going down, you get VGS. In order to get this point Q here, okay, you need to draw the line. Okay? When the intersection with the curve, that's the Q point. Now, in order to draw the line, the required you need to get one point here and another point here. Okay? Then you can draw the line and you can get the Q point. Okay? So, how do we get the point A in here? Okay? You can see basically VGS equal VG minus VS. Okay? VG equal 0. Nothing here. VS equal ID. IS or ID the same time RS. Okay? So VGS equal minus ID times RS. So we need 2 points A and B. First thing, I get the point A. I set ID equal 0. At this point here, ID equal 0. Okay? VGS equal 0. Okay? So that's why they said ID equal 0. VGS equal 0. So you get the point A. Okay? And now point B, you can set ID at any value. However, they have to greater than 0 and less than 10 IDS at 10 milliamp. You can pick any. Okay? So now, okay, let's see. I can pick the ID equal 4.8, okay, or 5 milliamp. Okay? That will be telling you, okay, in this example, they pick ID equal 10 milliamp. Okay, so ID equal 10, VGS equal 10 times 0.470 ohm. Okay, that will be telling you VGS equal minus 4.7 volt. You going up, you going right to left, you get the point B. And the point B. And now you draw the line, the intercept at the curve at the point Q here. And at the Q here, you go right, you get ID. You going down, you get VGS. Okay? You can see that a very simple way. They given you the curve. You need 2 points. Then you can draw the line. Intercept at the curve at the Q point. You go to the right, you get ID. You going down, you get VGS. That is the way to solve it for the cell buyer. If they don't want using the curve, they have to give to you some value. I given you example. They can say, okay, I given V, that's a VD, VG, VF. Okay. They say, okay, I given ID. Okay. So that means they given you the current flow here, ID. So now you don't need the graphic anymore. The thing is, the current ID, IS will be the same. ID, IS, 2 milliamp. So now you can calculate the VS. VS equal IS times RS or ID times RS. Okay? You can calculate the VD. Okay? You understand the VD? That's the difference between, okay, VDD minus the voltage drop across RD. Okay, ID time RD. Okay, so that means they must be given something else without the graphic to help you solving the problem. Okay, there's more example here. Okay, there's more formula. Guarantee you must be know. Okay, like VGS is what? VG minus VS. Then you can calculate the VS equal VG minus VGS, or VS equal ID times RS, ID equal VS over RS, and VG equal voltage divided the law. That means you can calculate the VG here for voltage divider. You take VDD times R2 divide R1 plus R2. This is just summary of voltage divider bias And for this voltage divider bias, okay, and they will be given the graphic so you can solve the problem, okay. And in here, they already telling you VGS. That means voltage here, voltage divider, okay. And now for the graphic here, you need same thing, point A and point B. And you draw the line from A to B, okay. Intercept with the curve at the Q point. You go to the right. You get ID. You go to down. You get VGS. Okay. That's how we can working with voltage divider. Okay. If they not given any more value, what you have to do, you have to draw 2 points. Let me draw the line. Intercept of the curve. You get that Q point. Okay. And now in here, they will be telling you, okay, how can you solve the problem? In here, they say right here. Okay. Finally, get point A at VGS equal 4.8 volt and a point B 1 milliamp. Now, how to get point A? They say set ID equal 0. Okay. ID equal 0. Then VGS equal, okay, VG minus VS. Okay. So they will be ID time IS. That means VS. Okay. VGS, okay, equal VG minus VS. That given you 4.8 volt. So this is the point A. Point A, okay, ID equal 0. So that's why you can get VGS point A, VGS equal 4.8 volt. So that's why 4.8 volt here. And another point, you can pick that point at this point right here. At this point here, you're going down. VGS equal 0. Okay. And now you need to calculate the ID. Okay. Point B. Okay. At ID equal 1.45. That means point B here. Okay. You need a VGS equal 0. Okay. VGS equal 0. Okay. So that's why you can get ID equal. They showing you right here. ID times 3.3. That means that will be Vs, okay? ID times Rs. And now, from this formula, you can calculate the ID equal 4.8 volt divided 3.3 K. Okay? Then you get 1.45 milliamp. Then you draw the line from A to B, intercept at Q point here. You go to the right. You get ID. You going down. You get VGS. Okay? That's just more example. If you want it, you can get the time. You go through it. Now, they're telling you here, I try to explain to you. This is a voltage divider bias. However, they said, I don't want graphic, so that's why I given to you VD equals 7 volt. Okay, now they want to calculate the VG. You know voltage divider. You can calculate the VG. Okay, and they want to calculate the ID. Okay, so basically, okay, ID equal VDD minus VD divide RD. That's how you calculate the ID. And now if you want to calculate the VS, that means ID RS. Okay? ID or IS the same. You want VGS. You know VG minus VS. Okay? You already know VG, VS. And the last VDS. VD. Okay? So that's a very simple, easy to do any calculation. Any question? Okay. If it's not, before we start with the amplifier, I want to give you a little quiz and you do it. Okay. And let me know you can get through or not. Okay. Let's see. Okay, now go ahead and try to do it. Okay? Go ahead and do it. Let me know. For one, A O B O C O D, do same thing. Okay?
Okay, I think I got it. Should I shout them out?
Okay, just a minute. Okay?
Okay.
1 minute. Okay, number one, A O B O C O D.
Got A.
Perfect. That will be A. Number two,
Anybody else want to take this one?
anyone get the answer, you have to do it. Okay? In order to understand it. If you're not, okay, just let us know. We're helping you. You spend the time in the Zoom. You really want to gain something. Who get the number two? They want VGSQ. Okay? Otherwise, you can tell me.
I got B.
Perfect. Look like you know what's going on. Okay, number three. G in. That means input impedance. When you're looking from the signal applied to the amplifier, how much resistance you can see. That's what they call input impedance. Okay, answer will be
I got B.
you get D, or A, or B, or C.
It's C. C.
Perfect. The thing is, you're looking into the amplifier. This is a 1 mega ohm resistance. Okay, that will be input impedance. Okay, now next one. This one is fixed bias for P and PJFET. So that's why they apply positive VGG and negative at VDD. This is the formula. Okay. So for P channel JFET, they want to know VGSQ. You have to do calculation. And I already given you the formula.
I got B.
A, B, C, D. You say B?
Yeah, I said B
Okay,
for
perfect. Number five, they want ID. That means you have to apply the formula. Who get number 5?
I think I put it for me is a C.
Correct. Okay. If you cannot get it out, that means after the meeting, you need to go into the video and try to do it. Make sure you get the right answer. In order to be complete technician 1, okay? The basic thing you cannot do it. What can I do for you? Number 6.
I got A.
Number 6 is B.
Number 6 answer will be B.
I got my signs messed up, Mr. Pham. But
Right.
number 6 is either 4.6 or negative 4.6.
Yeah, is it A? You said how can you turn it to positive?
Okay, they want VD. Okay, let's see. You're looking into the circuitry here. Okay, and VD will be the difference voltage between VDD and the voltage drop across 1K. Okay, then when you calculate the VGSQ, VGS, that means VGS in here, okay, you get the positive voltage 1 volt, okay, and that will be telling you, let's see, VGS will be positive, right? 1 divided to 4. 1 minus 1 divided to 4 and square. Okay? And time IDSS. That's why you get 4.6. The thing is VGS positive, not negative. Okay. Next. Voltage divider bias. No, that's cell bias. Sorry. Cell bias. However, we don't need the graphic. That's why they gave it to you. ID equal 5 milliamp. So 7.
I got C.
I did too. I got C.
A, B, C, or
C.
D.
I got C too. C.
C.
Perfect. C. Okay. Yeah, you're doing good. number, that's supposed to be 8. That's okay. The next number, they want VD.
I got A.
Perfect. You get A. The reason I given you the answer, the thing I want to make sure you get the time to make you able to solving the problem. Okay? The last part here. Okay? They want VDS and VGS.
I got B.
Which one you get?
I calculated and I got B.
You said D or C or B.
B.
You get B. Someone else.
I got C.
Perfect.
D.
8.94. Number 10.
You get it. So look like you're doing very well, you know. And the last one, 11. VGS.
Got minus 1.14.
Oh, man. Yeah, you will be a technician. No problem. That's just a basic. B. Okay, any question, anything. Okay. Normally, I don't want to turn in any answer. Only thing is, whatever we go through it, you understand how can you do it. Okay. That will be covered in the final test for this program for Tech Quad. So you have to make sure you know how to do. That's very good for me. Okay. Okay. Any question? Anything? Okay. The next meeting, we're talking about the FET amplifier. And after that, We're talking about MOSFET. Okay. That will be short. It's not too many things. And that will be very to the end of the lecture electronic. Okay. Then we can get a few weeks to review for you. Basic from a diode, bipolar transistor amplifier also. Okay. And the operation amplifier. That means inverting, amplify, non-inverting, follower, summing amplify. Okay. That means whatever basically technician one need to know on the basic. Then JFET and a MOSFET. And the last one will be active filter, but not too much. Okay, any question up to this point?
No, sir.
Okay, you get any question, anything? If you can do it, I feel much better. Okay, so if you already done almost electronic left one up to this point, then we get only 3 circuit board for JFET. You can add the lab instructor. You want to working on the JFET circuitry board. They will be given to you. Okay, we're on the way to buy more JFET circuit board. But take for a while. The thing ain't got too much. Okay, so I want to stop the meeting at this point. You have any question, anything? If you get the time, make sure you download the JFET amplifier. And if you get the time to reading over, that's much better for us for next meeting. Okay, any question, anything? No? Okay, so I wish all of you will get a very good weekend. Okay?
Thank you, Mr. Fan.
Thank you, sir. Thank you.
Yeah, we'll see you on Monday.
Professor,
Bye bye.
Good night, sir.
good night.
Night.